For this video, let's look at artificial intelligence and machine learning from a different angle. Usually we focus on the artificial and the machine part of it, but now let's look at the intelligence and the learning section. So when humans were the only ones we talked about having intelligence, our definitions of intelligence were kind of complex. But now that machines can learn, are intelligent, we now have a full spectrum from humans, animals, machines. We need a simpler definition, and here's one that's accepted. Intelligence is the ability to acquire and apply knowledge and skills. And that's something that the girl and the crow and the robot can do. How about the definition of learning? Well, acquiring, applying knowledge, skills, that's pretty much the same, isn't it? So maybe we can say learning is the acquisition and application of knowledge and skills. But there's one little twist. Often when we think of learning for humans, we think of kids in a school being taught by a teacher, whereas machine learning is more like self-learning. So as we think about machine learning, think about for the girl or the crow or the robot, self-learning. Let's look at a comparison of human and machine. So here's the Skydio drone. Its job is to take beautiful video shots from above, piloting itself, following an active runner or biker while avoiding obstacles like that tree branch. Now, we have 2 eyes. It has 13 cameras. One main camera, video camera we see centered in the bottom left is high-resolution color, beautiful composition for the scene. But the other 12 cameras are to help it figure out where is it in the world and what should its path be. So they're in pairs, just like we have 2 eyes for depth perception. They have 2 cameras looking forward, 2 back, 2 left, 2 right, 2 up, 2 down. And that's all for depth perception, for creating a path and mapping, giving a 3D map. So let's continue the comparison of human and machine. So here are characteristics that are strong in humans compared with characteristics that are strong in machines. And human, well, emotion and empathy, consciousness, initiative, creative problem solving, we know those are strong for people. For machines, well, they can be faster, they can be more accurate, they can be replicated more easily, they can connect to sensors and that sort of thing. So let's take a deeper dive by chunking them. So the human brain is embodied. Our body isn't just to carry our brain around, it's tightly coordinated, so our brain can control the muscles and receive data from things like skin sensors, all through our body, joint sensors. Our body is flexible, so we can flexibly apply our knowledge. Reaching high, lifting 100 pounds, and then a couple of minutes later threading a needle. We evolved in a social environment, so we have emotion and empathy. Emotion helps us to prioritize our attention. And empathy helps us to connect and identify the emotions of other humans. We're conscious, self-conscious. We have initiative, and we do creative problem solving, and our intelligence is a general intelligence, meaning that we can understand and learn almost anything given time. In contrast, the machine is usually way much faster. And it can be super accurate, much stronger, massive memory to hold fast streams of data from sensors. It can be economical, where it can replace a worker in repetitive tasks, but do that job 24 hours a day, 7 days a week with no sick pay, no days off. It's replicable, so once you create one that is working, you can download that to another one or manufacture more, and they all come off the assembly line the same. So the skill sets, the intelligence sets of humans and machines are quite different. They shouldn't compete because they're different. Actually, they are quite complementary. So a human and a machine intelligence together is almost a superhuman intelligence. And as a partnership, AI beats humans in games like chess and Go, but an AI and human team always beats the AI expert. So we often compare intelligence between humans and machines, but we rarely compare learning between humans and machines. Let's do that now. So machine learning can be much, much faster than humans, and it can be replicated. Once one robot or one machine learning system has learned, that can be implemented, downloaded into as many as we want very quickly, and they can continue to learn. The IBM Watson robot that competed against the two top Jeopardy contestants prepared by reading 200 million Wikipedia and encyclopedia pages. Maybe it took a week, maybe a month. Today's computers could probably do it in a day or two. But it could remember and access all of that information. In contrast, human learning is done on an individual basis. We start with a baby who knows nothing, and it takes that baby's brain 25 years to fully develop. All sorts of things can be learned and done before that time, but 25 years for full development, as opposed to immediately for a newly manufactured robot. So if that baby would read 30 pages per day, every day of her life, it would take her 20,000 years to read 200 million pages that IBM's Watson did in a couple of days. Wow. So big ideas here. We can reflect that skills that are easy for AIs to do, like math, are typically hard for people. But tasks that are easy for people, like empathy and creativity, are typically hard for AI systems. This is a recipe for a beautiful partnership between man and human. But in terms of learning, we should remember the real difference that a machine can be produced almost at birth with the learning that it needs, whereas every human needs that up to 25 years maturation process to learn what it needs to learn for its work and its future.